Hello and welcome back. We're going to look now at session 16. And here we're going to calculate the perimeters and areas. So let's get this up on the screen. Bear with me. Let's share this. Okay, lovely. So we're going to calculate perimeters and areas in 2Ds, including triangles, circles. So let's start. By the end of this session, learners must be able to calculate the area and perimeter of a rectangle, triangle, and square. Learners should be able to calculate the area of a triangle and area of the perimeter of a circle. And learners could also aim to calculate the area of a composite shape. Learners can be assessed on their ability to calculate perimeters and areas of 2D shapes, including rectangles, triangles, circles, and composite shapes. So areas, perimeters of rectangles, we have already met with the concept of areas and perimeters, but we'll now start to recap what we're looking at here. So here's a football pitch. Its dimensions are 90 meters by 45 meters. What is the area of the pitch? So the solution then is very simple, isn't it? It's the 90 times 40 gives you 4,500 meters square. The perimeter is 90 meters plus the 45 meters plus 90 meters plus 45 meters equals 270. So in other words, 90, 45, 90, 45. So that's the perimeter, but the area is the top one. So it's easy to confuse the two. Area is A divided by B. Perimeter is A plus B. You'll need to be familiar with both these formulas and know them off by heart. So when we move forward. So if we look at the design of a football pitch, the length dimensions of the football pitch of the Premier League, the length is 90 and 120, and the width is 45 and 90. What is the maximum possible area of the perimeter then? So if we look at the maximum areas then, so we're looking then at the 120 times 90, which is 10,800 square meters. And the perimeter is 2 times 120 and 90, which is then 420 meters. So we're going that way. What is the minimum possible area? So then that's the smaller number then, which is then the 90 times 45. And then the perimeter is just added up. So again, relatively straightforward. Why do you think that these are the current rules? So if we look at the area of a triangle, here's a triangle. The base length is 10 centimeters. So that's this bit here. The height is 15. So from the top down. Area is half. So if we think of half of that is times 10 times 15 square meter equals 75 square meter. This, in fact, half of the area of the rectangle, the dimensions of 10 centimeters, 15 centimeters, see the dotted lines. So again, here, if we look at that, the triangle is half of that. So if that makes sense. So we do 10 times 15, and then we just want half that. So the formula for the area of the triangle, the base length and length A and the height is half times base times height, and the area there is half base height. So example, if we look at this shape then, what area of the shape is shown here? So again, here we can look, it's 3.5 centimeters there and long and 2 centimeters width. So the area of half is 3.5 centimeters times 2 equals 3.5 centimeters square. So there's a useful box here that I'm just going to fill in. So again, here, if we think of triangles, complete the tables there. So have a practice with those and just make sure you're used to them. So areas and perimeters of a circle. So this is where we go to the center. We get the, we come out. So the formula for the circles are very important shape as they're completely symmetrical. We call the perimeter the circumference of the circle here. And you will need to know this for the formula. So the area there and the circumference here, O is the center of the circle, and then you've got your radius there. The diameter is twice the radius, so from there to there. So what is the area and circumference of the circle? Is 4 centimeters. So to work this out, then you would do the area. So 4 centimeters times by 4 centimeters equals 16. And to one-dimensional place, this is 50.3 centimeters. So the circumference is given here in this formula there. And then that has a one-dimensional place of 25 to 1 centimeters. And again here, we'll fill those tables in. So have a look and just make sure that you're happy with that. If we look at composite shapes, here's an example of composite shapes, what we want to calculate in the area. There are a number of ways to do this. This is by dividing the shape into 2 or 3 rectangles. One way of doing this is shown in the dashed lines here, so we can break that down, and now we've got 2 separate rectangles. We could do this one here, and then this one here. So we've got 14 times 20 plus 15. That's there. Oh, for some reason that's not finished the rest. And then we would do 14 plus the 12 there. Okay, that's there. So that's that one. And then we would work out this one. So then it's 15 by that, and then that will give us that. So aims of the outcomes: calculate the area and perimeter of the rectangles, including squares. Learners should calculate the area of the triangle and the perimeter of the circles. Circles are the composite shapes. Calculate perimeters and areas of 2D shapes, including rectangles, triangles, squares, and composite shapes. Don't forget to give your activities a try, and don't forget to do your worksheets. So again, just go back and make sure that you've done your self-check-in, which is... Oh, hang on. Where are we? Here we go. Number 16, areas and perimeters. Okay, lovely. Good luck, and I'll be back for volume and surface.